Hey there, math friends. Welcome back. Today we're going to take a look at writing and solving inequality statements. And the thing about writing and solving inequality statements versus writing and solving equations is that when you write and solve an inequality, there's an extra step you have to do. Remember, every equation that you have to write, I always teach that you have to have, there's a total on one side, that's the goal or whatever, and then the other side is the how. How mathematically do we arrive at that total? When we're solving inequalities, at some point, after you've written down your equation, then you have to ask yourself, can the side that's on the how, can that side be more than the total? Or should it be less than the total? Can it be more than or equal to the total? Or can it be less than or equal to the total? And you'll find out more about what I mean by that when we take a look at this first question. So it says, under her cell phone plan, Genesis pays a flat cost of $40.50 per month and $5 per gigabyte or part of a gigabyte. For example, if she uses 2.3 gigabytes, she'd have to pay for 3 whole gigabytes. Now, she wants to keep her bill under $55 per month. What is the maximum whole number of gigabytes of data she can use while staying within her budget? So, let's take a look at what we've got going on here. We have to answer the question. What's the question? What is the maximum number of whole gigabytes that she can use to stay within her budget? Okay, and let's take a look at some numbers. $40.50 is the amount that she pays per month. That's a flat cost. She's going to pay that no matter what. And then it's $5 per gigabyte. Okay, and she wants to keep her bill under $55 per month. So the bill needs to be under $55. So $55 is the bill. That's the maximum bill. No more than that. Because she wants to keep it under 55. Okay, so now we have enough information that we can start to write our equation based on the how versus the total. So let's get started with that. I'm going to put my equal sign here. Now it's going to be an inequality, but I'm going to start this off as an equation. What's the total here? Well, she wants to keep her bill under 55, so that's going to be our total. The limit is the total. Her limit is $55. And how does she arrive at that total? Well, she's going to pay $40.50 no matter what, plus she's going to pay $5 per gigabyte. And we got to think of a variable to use for gigabytes. I'm going to let G equal the number of gigabytes. Okay, so $5 multiplied by the number of gigabytes. All right, so now we have to ask ourselves, now that we have the equation written, we have to change it to an inequality. Can this side that I have highlighted here, the $40.50 plus the $5 per gigabyte, can that be more than $55? No, because it says she wants to keep it under $55. So it has to be less than $55. So whatever happens on this side has to be less than $55. So, now can it be exactly $55? Can it be less than or equal to? Well, in this case it can't because it says she wants the bill to be under, okay? Not $55 or more or $55 or less. It has to be under. That means less than $55. So, now what I'm going to do is I'm going to rearrange the other side over here so that I have my part with the variable, the coefficient and the variable, the $5 times G. I'm going to have that first. And then I'm going to have the $40.50 added to that. Because now I can solve the equation using inverse operations. To solve this inequality using inverse operations, I'm going to undo the addition by subtracting $40.50 from both sides. These two will cancel each other out, and that will leave us with $5 multiplied by the number of gigabytes is less than $14.50. Use the old calculator there. And now my next step is to undo the multiplication. This is $5 times the number of gigabytes, so I'm going to divide by my $5, both sides of the equation. Those two cancel each other out, and G is going to be less than $14.50 divided by $5 is 2.9. Now, we have to ask ourselves at this point, because it has to be a whole number of gigabytes, because that's what G is. Can it be 2 or 3 gigabytes? Because we have to either round down or round up. And if we want to keep it under $55, we're going to have to round down. So G is going to have to be less than 2 gigabytes. Because if we round up, that would round it up to 3. And 3 gigabytes times $5 is 15. That would be $15 plus $40.50 would be $55.50. That's more than $55, so we can't. Because it has to be less than, we had to round down. Okay. Round down. And I think that's because this has the less than symbol there. It wouldn't make any difference if we were just solving a random inequality, but because this has a problem attached to it, we have to do it that way. Okay, the next question says, Caden needs to order some new supplies for the restaurant where he works. The restaurant needs at least 652 knives. At least 652. There are currently 382 knives. Currently, that means that's what they have right now. If each set on sale contains 12 knives, what is the minimum number of sets of knives Caden should buy? So this is our question. What is the minimum number of sets that he should buy? Okay, well, let's lay out all our information. They need 652 knives. They have 382 knives. Each set has 12 knives. And we have to come up with a variable to represent to answer the question, the minimum number of sets. So we're going to I'm just going to let X represent the number of sets, because that's what we're looking for. The number of sets of knives. Knives. I'm having a really hard time writing the word knives today. Okay. There. Now we can begin to write our equation in the how equals the total. I'm going to start off with my equal sign. What's my total? Well, my total is they need 652. How are we going to get to that total? Well, the how is they already have 382 knives, and then Caden is going to order sets of knives. We don't know how many, but there are 12 knives in each set. So 12 multiplied by the number of sets of knives, and that will get us to the 652. Now, this is the point where we have to ask ourselves this question. Can the how side, can that be more than 652? Is it okay for there to be more than 652 knives? Of course, because it says at least 652, and at least means it has to be 652 or more. So we can, yes, this side can be more than 652. Can it be exactly 652 if we want it to be? Yes. They can order so there's exactly 652, or they can order so there's more than 652. And then, as you can see, on the how side, I have the part that has the variable in the second position. I'm going to put it in the first position because that's the best place for it. 12x plus 382 is greater than or equal to 652. Now we have our inequality that we can begin to solve it. So, the steps in solving: we will undo the adding of 382 by subtracting 382 because that's the number of knives they already have. So those will cancel each other out, and we get 12 multiplied by the number of sets of knives is greater than or equal to 652 minus 382. You can hear my calculator. 270. And now, the next step is to undo the multiplying here. 12 times x, we divide by 12. 270 divided by 12. And remember, this cancels out on this side. So x is greater than or equal to 270 divided by 12 is 22.5. Now we have to ask, because you can't order a part of a set of knives. It can't be 22.5. It has to be either 22 or 23. Now, if you guessed that we should order more than or equal to 23 sets of knives, then you are correct, because the number of knives that he has to be greater than or equal to 652. So that being the case, we would definitely want to round up, because we want that amount to be greater than. We want the part that's highlighted, we want this side to be greater than 22.5. So we have to round that up because it's a real world problem. Great. Well, let's move on to the next one. This one is a little more complicated. Not too bad, though. Mav has $560 to spend at a bicycle store for some new gear and biking outfits. You know how people are, they get into cycling. They got all that fancy bicycling equipment. Assume that all the prices include tax. Okay, great. Remember, she has $560 to spend at the bicycle store. So that's how much she has to spend. She's going to buy a new bicycle for $425.05. She's going to buy 4 bicycle reflectors at $15.19 each, and a pair of bike gloves for $15.79. And then she plans on spending the money, the rest of it, or some of it, on whatever's left, to buy new biking outfits for $29.20 each. Biking outfits. We want to write and solve an inequality that can be used to determine O. Well, I'm not going to use O because O's looks like zeros. So I'm going to use X, the number of outfits that she can purchase and stay within her budget. So she has $560 to spend. She's going to pay $425.05 on a bike. She's going to spend $15.19 each for 4 reflectors. This is just all the information, right? And she's going to spend $15.79 on gloves. In case she wrecks, she puts her hands down, she won't tear up her hands. You got to have those gloves. And then the new outfits are $29.20 each for new outfits, shorts and tops. And we don't know how many she's going to buy, so we're going to let X represent the number of outfits. This is all the stuff you have to do in order to write this inequality correctly. So, if we're going to write the equation with an equal sign, well, what's her total? What's her limit? In this case, it's $560. I'll put the decimals there. How is that money going to get spent? Well, let's see. She's going to buy a bicycle for $425.05, plus she's going to spend $15.19 each for 4 reflectors. So I'm going to have to multiply $15.19 times 4, because 4 sets of reflectors at $15.19 each, plus the $15.79 for gloves. Oh, I'm going to have to move stuff over here, pardon me, plus then she's going to buy those new outfits, $29.20 each, but we don't know how many, so we're going to multiply that by x, our variable, and that's going to equal $560. Decimal. Okay. Well, the thing we have to look at here is we've got all this stuff over here that's going to get spent, right? Is that going to be more than or less than $560? Can she spend more than $560? No, because that's all she's got. So this side has to be less than the $560. Can she spend exactly $560? Of course, because that's how much money she has. And that's what she's going to try to do. Now we have to simplify this side that's highlighted in pink. The first thing we're going to have to do is figure out what 1519 times 4 is. 1519 times 4 is $60.76 plus the $425.05 plus the $15.79 and then the $29.20 for the outfits. All right, we should combine like terms at this point, and all our like terms are the ones that have no variables. All of these are like terms. So let's combine $425.05 plus the $60.76 plus the $15.79. I'll do that right now. $425.05 plus $60.76 plus $15.79. And that equals $501.60 plus $29.20x is less than or equal to $560. Great. Now we can solve. Oh, after I move stuff into the right positions. One more chance here. 2920 times x plus 501.60. It just makes life easier for solving if we put the part with the variable out in front, the term that has the variable out in front. Now we can solve easy peasy. I'm going to undo this addition by subtracting $501.60 from both sides. And on this side I get 5840. This side, those two cancel out, and I end up with 2920 times x. And now I divide both sides by the 2920 because that's what's being multiplied by the x here. So I have to undo that multiplying by dividing both sides by that. And x is going to be less than or equal to, let's see, 5840 divided by 2920, that's exactly 2. 2 biking outfits. So when she is all done, she can buy x, she can buy less than or equal to 2 biking outfits. So she can buy 1 or she can buy 2 biking outfits. Okay, I hope this helped you in the quest to be able to write an inequality and then solve it. Remember, you have to ask yourself, On the how side, let me go back up here. You have to ask yourself on the how side versus the total, can the how side be more than or less than the total, or more than or equal to or less than or equal to the total? Those are the things you have to critically ask before you begin to solve your inequality. All right, well, we'll see you next time. Good luck. Have a great rest of your day, and don't forget to be awesome.